All right, so when it comes to the analysis of one-way ANOVA, we have to remember, assuming that have a little bit of a background of ANOVA, you have to run the model. And so in order for you to run the model, what I'm going to do is define the model as ANOVA model _1 is equal to AOV. AOV is just analysis of variance to function within R. And as you can notice, I forgot to do something. Always run library stat cal poly package. Sorry about that. Okay, great. Okay. So you do BWT tilde race. Okay, so BWT is your quantitative variable, and your the race is your categorical variable, and more specifically, it's always going to be explanatory variable tilde then your response. Okay, explanatory tilde your response. So you can say response tilde if you're reading left from right. Response tilde explanatory. You saw the same thing with t.test, so this is nothing crazy. And then from there you would say data is equal to King County. So when I run line 1, I run line 2, and that's great. And so you say, why am I saving this output, or why am I saving my model? And the reason why I'm saving it, or at least the reason why I'm saving it, is so that I can have access to it. Because if I just look at the model as is, it's giving me a whole bunch of junk, and it gives you a lot of stuff that we haven't spoke about or won't have time to talk about. But in terms of the table that we talk about, if you do summary of your ANOVA model 1, okay, it gives you the table that we talked about: your degrees of freedom, your sums of squares, your mean squares, your test statistic, which is your F value, and the corresponding P value. Okay, so you're able to get all this. And so as you can notice, you're going to decide to reject your null hypothesis, right? And so with the small p value. But let's say you wanted to find the critical value first, if you just wanted to double check. What you can then do is do QF, that's the critical value for F distribution, 1 minus 0.05, because that's your alpha, and your degrees of freedom from your F table, or from the table, is 4, that's for between. And then for within is 2495, and then you run this, and it's going to give you your critical value, 2.3754. That's your critical value. Okay, so that's what you should compare your test statistic to, so that you can determine what you're going to do to your null hypothesis. So we know we're going to, of course, reject our null hypothesis if you compare this critical value to this test statistic here. Okay, so since we know that we're actually rejecting, we know that we can then now implement implement the method of determining which of the groups are different from one another. Okay, so the function we're going to use is called Tukey HSD, and then you start typing ANOVA. Again, this is the reason why we define our model, and we store within ANOVA model _1. And so when we run this, we're able to then see all the confidence intervals comparing each and every group. Okay, so Black versus Asian, Hispanic versus Asian, other versus Asian, and so on. So what this gives you is your lower bound and upper bound. It gives you your difference. Sorry, I should emphasize that. It gives you your difference, and it gives you your lower bound and upper bound for your plausible values for the difference. So it's essentially doing a t-test for each of these pairs. Okay, and then you can see the actual groups that are actually different from one another if they're both the same sign. So these both are positive, so you can see there's a difference between white and Asian. Okay, what else? White and black, you can see that because they're both positive. Okay, great. And then you can see that in terms of, I think that is it. I think that's it. Okay, well, there you go. And so now you have the capacity to analyze ANOVA within R.